recording going, so let's start looking at a recap of study unit 9. So basically going to look at hypothesis testing. Again, just a few questions we will work through, and then at the end you will also see that there's again some of the notes that I just included again so that you have it. So you can just again keep this as assistance for the exam, that you have extra notes on the subject. Okay. Again, like last time, we're going to use this table for the 1 and 2 tail. We know what the confidence level is, or if they give us the alpha, then we can use this confidence limit as the Z in your hypothesis testing. If we need to work out with a t distribution, we will go, and I'll show you again on our t table where we will find that. And then I added one extra. I might not be sharing, so let me quickly check. Let me just share again. Is it sharing now? Cool. Okay. So basically just showing the it. Let me just on my side see what happened now. Cool. Okay, so one tail, two tail, depending on what is in the question with hypothesis, we will be able to use the Z's. T-table, we look at the T-table, we will decide on the degrees of freedom and the alpha, what we will be looking at. And I think the first question actually has something like that in it. But then also just for you guys, so that on the one slide, it's sometimes easier also to see certain of these things. So if we have a two tail, remember the p-values is both of the two tail. If you have a one tail, doesn't matter the lower one or the upper one, your p-value is sitting just in one of the areas. And then also we did some rejection areas, so also nice that everything is just on one slide for you guys to also, if you go through, I don't know again when it will be up and running, but if you go through the mock assignment, that you have this piece of information with you as well. Okay, so today just going through actually one of each of the scenarios. So not a lot of questions that we're going through, but I just wanted to put in nearly a question of each each type of problem that we can get. But I also included a, a question that I haven't seen in quite some time. Um, so let's just read it and see what it says. So consider a two-sided hypothesis. There is your 5% level. They tell us 25 degrees of freedom. So that already tells us degrees of freedom. If the population standard deviation is unknown, what is the critical value? Okay, so we must go and find that t-value where we have a degrees of freedom, and let's just write for alphabet. It is, and let's get alpha divided by 2. Okay, so that is what we're going to look for. Again, that is where you start using the t-table. The t-table again, it is in two places. So it is in your study guide, or it is also in the study letter 101. So we go down to the t-table. Okay, so the first one is normally the z-tables. And here we have the t-table. Let's just, and we're looking for, they already give us the degrees of freedom. It's 25. The degrees of freedom, 25. Interesting that they could have said to us the sample is 26 or something like that. But they give us the degrees of freedom already, so you don't need to subtract 1. So of 25, and it was for the level 5%, two-sided, so it is 5% divided by 2, which is 0.025. Okay, so let's look for that value on the table, 0.025. 0.025 with that 2.0595. Let's see, 2.0595. So it's rounded off to 2 decimals. So that option would be the one that we are looking for. Okay, let's just check if you said 5% and not divided by 2. So if you said 0.05, 0.05, there's a number 1.71 probably. 1.71, there is an option. Okay, so just be, again, very careful. So if you looked at the 5%, but you thought it was 0.05, so there's 2.79. Okay, luckily not something like that. So would not have made that mistake. But if you were only looking at the 5%, there would have been something for you. Okay, so again, in this instance, just be careful. Um, Interesting that they didn't do something around um, n equal to 26 or to 2024, because that also might be sometimes what they do, because they give you the degrees of freedom. Okay, so I thought let's include something like this, um, where they just ask you to basically go with this numbers and variables, go to the t distribution, and to then source the number that you are looking for. Okay, so let's go into more of the finer details. So basically, hopefully, I think there is now three questions. So one on proportion, one where the population standard deviation is known, one where it is unknown. So I'm hoping that was for free that I put in when I created this. But let's look at the first one. So in testing the hypothesis H0 against the alternative bigger at the 5% significance level, if the same proportion or the sample proportion is 0.45, sample size 49, which one of the following statements is incorrect? Okay, so let's first look at alternative hypothesis. Alternative hypothesis is one directional, so it just shows you going to one side. So by that, it is a one side or one tailed is used. So that is correct. Then they ask us the standard error. I think this is one that we saw in the week as well. They love asking the standard error question, because then also it's sometimes easier just to work out what your critical value will be. So let's quickly see. It's 0.4 times 0.6 divided by, what is the sample, 49, and the square root of that. So let's quickly check what is that answer. 0.4 times 0.6, I get 0.24 divided by 49, 0.049, and if I take the square root of it, I get 0.07. Okay, so let's just, that would have been my incorrect one. I have included the answers for you. So yes, we can see that is the one that is incorrect. So again, a small mistake that they're making, that one can easily mislook, because there is a 0.07. I look at the answers, I see a 0.07. If you look very quickly, if you're under pressure, very easy to miss this one. So again, just be very careful when you're working and you're looking at the answers. They love bringing in these kind of things. Um, yeah, so just be very careful when you work it out that you're not caught just by a simple mistake on the paper. Okay, then critical value. So let's look at critical value. They told us we sit with a 5% alpha. Okay, let's quickly. So the 0.6 is coming from that 1 minus, which is 1 minus 0.4. That is where the 0.6 is coming from. And so it's from that formula. So 1 minus the 0.4 will give you the 0.6. Okay, happy with that? Cool. Okay, critical value. So test at 5% level to see where is my. I'll definitely change colors now. 5% level, one-sided. So when we go to the table, remember that is your alpha. So we test at 5%. We test at one tail because that is what they told us. So we've got a critical value of 1,645. If I look at it, critical value of 1,645. So that is also correct. So by just using the tables that they've supplied us in, I think that was even in study unit 8 that they've given us that table. So I think this table is really important to be able to use and to use in study unit 8 and 9, because then you don't need to go to a Z table or anything like that. So then it is easier to do that. So again, use the notes. I will again send you guys this afternoon the PDF that I also have created of all the study units. I've specifically for study unit 8 and 9, I've brought in some of that already in the notes as well. Okay, then work out the test statistics. So that is normal how we would have done in study unit 7. So that is a lot like what we've done in study unit 7. So, and nearly the importance of study unit 6 and 7 for nearly the rest of the work, because we use it on a continuous basis. Okay, so we've got the sample proportion 0.45. So they've given that to us. We subtract the population proportion, and we already know that the standard error that's here underneath the line, we've already worked that out as 0.07. So we don't need to go and work it out again. So 0.45 minus zero point 0.4 is 0.05. That divided by 0.07 gives us the 0.7143, which is that T-stat. Okay, now they want us to work out what the probability is with that T-stat. So remember the zero. So here they told us it's 0, and we will round it off so that we can use the table. So 0.71. Remember bigger. So we need to work out what is this area here, which will be the p-value. Reason why we're working out this area is because the null of alternative hypothesis tells us that we need to look at it as bigger. So they want actually for us to find out what is the probability that it is bigger than the sample proportion. So again, I don't know off my head what Z 0.71 in proportion or in probability will be. So we can do two things. We can use the negative table Z minus 0.71 to get the blue area. So let's first do that. Minus 0.71 feels like, let's just check. So 0.2388. 2388, so it is rounded off to 0.2389. So there we have it. But we could also have said, well, I'm going to use the positive table. The positive table is going to give me the green area. Then I just need to say 1 minus the value that's on the positive side. So let's look at 0.71. 0.71. So 1 minus 0.7612. 7612. And if you then do that calculation, 1 minus 0.7612, you will also get the original 0.2388. Okay, so again, both ways you can use to get to the value. Again, all on what is easiest for yourself. I love to go to the negative table, but if you're more comfortable in using the positive table, subtract 1 from it, get your answer, by all means, you get the same answer. So no problem in which one you use. Okay. So hypothesis testing, they will tell you. So you look at the alternative hypothesis, and because it's bigger than its one tail, the only time you will have a two tail is when your alternative hypothesis is not equal to. So whenever it's not equal to, that's the only time you will have a two-tail. Else you will have a one-tail. So um, the most important one nearly to look for is in your null hypothesis versus your alternative. So in your alternative, uh, not equal to is two-tail, then bigger, smaller, bigger or equal, smaller or equal, all of these ones will give you a one-tail. So that is nearly how we will always look at it from a one-tail and a two-tail. Um, that is the process that we will follow. So your alternative hypothesis will indicate to you if you're using a one-tail and a two-tail. And the only time it is a two-tail is when you have a not equal. Else it will always be a one-tail. Okay. So that is how we will look at it. So in the when it was still a paper-based exam, I would normally have gone and said, okay, bigger one tail. Let me go to the next question. Okay, not equal to, then I know it's a two tail. Next question. Okay, yeah, they tell us I must try and find something, so I don't know. Um, so that is nearly the process. First, look at your hypothesis, what it says. Um, this one told us one tail, and then nearly remember then in everything else that you need to calculate, you will always then refer to one way. Yes. So chapter 8, and that is also important. So in chapter 8, because you're looking at confidence intervals, it's always two-tail. So confidence interval, because you've got your mean, then on the left-hand side, you will have your lower confidence limit. Other side, your upper confidence limit. So in study unit 8, doesn't matter what they tell you nearly in it, you're working with a two-tail because there's always a lower tail and an upper tail, always a lower confidence and an upper confidence, even though they don't always say it to you. But if I go back to this one, in your study unit 8, it will always be I'm working between those two because I want to understand how it is spread around the mean. And so you will always have your confidence interval around something that you're working out. But with study unit 9, we basically here working with I've made a statement. I don't want to get what is if this mean falls within a certain level or certain upper and lower level. I want to find out with hypothesis testing if my hypothesis is different from what the population hypothesis is. So the hypothesis testing is nearly every time that you're doing a hypothesis test, it is there's a statement and somebody wants to say, well, they disagree with that statement. So in this one, if this was written out In words, it would have been something like the the population proportion for the success of left-handed steering wheels or something like that is 0.4. Then somebody else says no, but for Toyotas, they believe it is more than 0.4. And then you do the problem to say to them, okay, but listen, if we've worked it out, if we look at the t-test, if we now look at this high p-value, there's nothing in here that tells us that Toyota is different from the normal population of cars. So that is nearly how they will phrase it. So let's look at, I think one of it, no, so that last one, we will need to decide on how the hypothesis look like. What I did for you guys, I have included the answer set. So if you just again wants to run through the answer set, it is included in the slides as well. Okay, so let's look at this one. So interesting, I actually only have proportions in this one. I will, for our prep next week on study unit 8 and 9, I will get a nice spread of all the questions that we will have in study unit 8 and 9. So don't worry, we will on Tuesday have a nice spread in the questions. Okay, so question 18. So a random sample of 200, 88 are defective. The tutor is testing the null hypothesis. Again, we go null hypothesis is equal to 0.4. Alternative hypothesis is not equal to 0.4. Okay, so that tells me we're working with a two-tail. Okay, so let's see 5% level of significance. So if we go to that table, 5% significance, remember two-tail, 1.96. Okay, so we now suddenly and we might not need it here because we want to work out the p-value, but if I needed to use it to work out, my critical value would have been 1.96. Does not seem like it's one of those previous questions. We just need to work out what is the p-value. So we would need to work out with a z-test a value. I'm not going to draw it yet. And then we need to work out what the p-value is. So let's do the z. Remember, this again is from this formula that we did in study unit 7. Divided by n. And what I've done, you will also see here after the slides, I have added all the the definitions and the processes for you. So it is not, so it is all part of a pack that I will share. So all the definitions and the theory is included. Okay, so let's look. What is the proportion of a sample? So it's 88 divided by 200. Let's quickly see what is 88 divided by 200. Okay, 0.44, so it's not going to be that big a difference. So we've got it 0.44 minus the population one, which was 0.4, divided by 0.4. Again, my shortcut 1 minus 0.4 gives me the 0.6. And the sample is that 200. So also just, oh, not 800. Just sometimes be careful that you don't miss that 200, because you use it to calculate what the sample proportion is, and sometimes then one forgets that, oh, that is actually the n that I'm also working with. So um, let's quickly check. 0.4 times 0.6 is again with 0.24 divided by 200, 0.0012. And if I take the square root of that, I get 0.0346, but I still need to say that minus that, so 0.04 divided by that option. I get Z is equal to 1,1547. So it will probably Z be equal to 1,15 that I will work with. You can now see that might have been the Z that they worked out. Again, we were looking for a p-value, so we're looking for probability. Probability can't be bigger than 1. So that is probably more likely the Z that they have worked out with their calculation. So let's now look at not equal to. Remember, not equal to means that it is two-tail. So my Z here is 1,15. That is my probability. So let's go to, again, negative table, 1, minus 1,15 minus 1,1. Want to see if it is that one. Oh, okay, 0,1251. 0,1251. Okay, so if that side is 0,01251, so I just want to check if we were working with 1,16, 1,1, okay, so 1,16 is the one that we are going to work with. So let's just remember, but the same principle still applies. So if we have two-tail, what must you do with the p-value? So on this side, there's a probability because it's two-tail. On the left-hand side, there's also a probability. So you will need to add the two together. Okay, so very important with two-tail is that the one-tail, we just needed to get that p-value of a one-tail. But of a two-tail, we will need to add the two together. So you will always have in your answers, there's the one if it was only the one tail, and there's the one that if you multiply it by 2 or if you add the two together, that you will get the two tail. Okay, so very important. If your question is around the one tail, you will only include the one tail in your p-value. So if it doesn't matter if, so this one was a bigger one, you would include that. If it was a smaller one, that would be your one tail for small. That will be your one tail for bigger. If you have the not equal, that means you have the two tail. That automatically means that you need to have both of them as your p-value. And so when you have unequal, which tells you two tail, then automatically you will have both of them as two tail. Okay, so you will need to add the two p-values for the two tail. You will not look at the area between the two tails nearly. So you will need to work out like we did in chapter 6 and 7, where you will work out what that probability is. So the only thing now is with a two tail, you will take the probability on the right hand and you will add the probability of the left hand. So think about it nearly as in study unit 7, where we nearly said something must be bigger, something is smaller, and you got the two probabilities. That is how the two tail works in that instance. You will take the two probabilities and add it together. Okay, I just want to see why their answer. Okay, so they also got, like I did for 1,15, but then suddenly they made a mistake when they looked at the answers. So you could definitely see we were correct with a 1,15, but then also somehow there was a mistake when they looked at the answers and suddenly changed it to 1,16. That's why our original numbers does not align to that, because somehow they worked with 1,16. Okay, so again, if something like that is happening in your assignments or in the exam, you guys let me know, so that one can let the lecturer know, because here we can see it was 1,5, so probably there already they made a mistake with that one, and it just a ripple effect through everything else. Okay, but yeah, if you get something like this in the assignment where you see what you worked out and you checked it, you let me know, and we will just update the lecture, and then again will fall out of one of the questions that you are doing. Okay, so let's go to the last one, where they give us lots of information and you need to decide which one of the hypotheses is the correct one. Even before I nearly read this, I'm like, okay, remember when we write the hypothesis, what signs do we use? So we don't really use the sample. We would normally say your population is one size and that differs. So we don't really say the sample. So if I look at these options, I'm like, okay, that one is probably not going to be, because we're looking at sample. Option 4 not going to be, because we're looking at sample. So let's read through the question and see how they actually got to some of these. So a random sample of 10 public swimming pools in a province is selected with a pH value determined. The sample mean for the random sample is x is equal to 7.3, so that's the sample mean. So already you can see when I reference the sample mean, I should have also referenced 7.3. Okay, so option 1, definitely not. Option 4, definitely not. And then they tell us what the standard deviation is. The claim made by the swimming pool administrator is that the pH value of the swimming pools is greater than 7.5. Okay, so that tells me my H0 is, well, gonna say it is 7,5, because my null hypothesis states that this is what it is. Your alternative hypothesis is the one that somebody comes and say, hang on, I don't trust your number. I believe it is greater than 7.5. Okay, so your null hypothesis nearly is always the one that this is what we know. We know it is 7.5. And then somebody else comes and say, no, but your 7.5 is wrong. I think it is greater or smaller or not equal to. So in this instance, the null hypothesis equal, alternative hypothesis bigger than. So let's see, null hypothesis equal, alternative bigger than. So it is option 2. If my null hypothesis said the p-value of swimming pools is smaller than, then if it was smaller than, and as you guys now know, some of you will get the bigger than, some of you will get the smaller than, there was the smaller one as well. And then somebody else could come and say, but hang on, I think that your public swimming pool is not equal to 7.5. And by saying not equal to, you basically get the not equal sign. So again, if we needed to go further with this one, that would have been a one tail, that would have been a one tail, and that would have been a two tail. But then the right option is option 2. Also important that because we say the one is bigger, don't go and now say that your alternate or your original one is smaller or equal. Say doesn't work like that. Your null hypothesis, the statement is always your mean is equal to the population mean. So you or your proportion is equal to the population proportion. So you always go in with hypothesis testing as my null hypothesis is the true hypothesis. So it is always the one that is, I believe this is equal to. And then somebody else must come and say, I'm sorry, but I disagree with you. So I think your alternative must be bigger, smaller, or not equal. Okay, so your null hypothesis is always the one that everybody says is the true one. So that is the one that is always equal to. And if they probably just did a bit on that in the answer set. Yeah, so, but I think it's important for you guys, and that's why I added things into this again. So, and I will make sure that when we do the prep for your next assignment, that we will basically in the prep do and let's take this away. So what we will do in the prep is, and just to make sure, so in study unit 8, so that we can see the alignments, we will do confidence intervals. So you will do the confidence interval where we have this one where that is known. Let's just write it something like that. So then you know that's a confidence interval, but then in my hypothesis test, we will do that where we test maybe something like that, but we know also have a standard deviation as known. So that's how I will make it for us in our prep. Then we get the T. So on a confidence interval side, we will have a T when your population standard deviation is unknown. And then again, we will do it also for your study unit 9, where we will have the T and degrees of freedom and all of those. So again, nearly see how to do it with the confidence interval, then see how we do it with hypothesis, and then the proportion one that we will also again do in both. So that for me is nearly the important thing with our recap of study unit 8 and 9, is to show you some of the similarities between the two, some of the where a Z value is on the one side in study unit 8 exactly the same as for one in study unit 9, and those things that again um, in if you look at study unit 8 on its own, it's very difficult. If you look at study unit 9, I still believe hypothesis testing is one of the more difficult um, units in this subject. But if you see the two together, then sometimes it does become a bit, the understanding is better and it does become making more sense. Um, so that's, I will make sure when we do the recap of the study unit 8 and 9 that we also work it out like that for you guys. Okay, everyone. That is it for today. So a quick recap of study unit 9. There is some of the definitions and literature in as well. Um, on Tuesday, we will do a recap of study unit 8 and 9. I'll share the link with you guys. And then on Thursday, again, we will do a recap of study unit 8 and 9. And then whenever the assignment 4 is made open, we will, before that, just do another quick check-in. But else we will not next week, the week after, we will continue with the other study units until we need to do a check-in again. Yeah, for me, chapter 9 is the most difficult one. Um, because also what makes chapter 9 difficult is you need to know nearly all the work from chapter 6 you using in chapter 9. So 6, 7, 8 you using in chapter 9. So you need to know. So if I look at these steps that one needs to do, so you need to know hypothesis, what's a null hypothesis, what's the alternative, how you're going to phrase it. If I don't give it to you and it's said in words, you need to know what is the alternative. Is it bigger? Is it smaller? Is it not equal? Because that makes it a one or a two tail. Then, and let's make this one much bigger. We can always make it smaller again. So yes, you have now this step 2 that you now define. If it's bigger, smaller, or not equal, it will have an impact on your alpha that you're using. So if it is a one tail and we had a 5% alpha, it's 1,645. If it was two tail, it's 1,96. So automatically, by having the null hypothesis and alternative right or wrong, can have nearly a ripple effect on the rest of your calculations. And that's what make this one so difficult. So you can exactly know then how to work out the Z. You can, if it is a T, you can work out exactly the T if it is the proportion. But then suddenly, because the alpha, you might have it wrong, you're going to test it when you look at the critical value against maybe the wrong critical value. And that then just snowballs more into what might go wrong. You might then pick a different p-value because so very important chapter this nearly in all of the things because yes we did in chapter 7, the level of significance we did in chapter 8, the same if it was known or unknown, but then you bring in just a bit more and suddenly you need to make the decision, is it one tail or two tail? They don't always tell you that, and that's why it is so important where was it? When we look at the certain things that very important, nearly, and how I remember it, there's only one time that it is a two tail, and that is when the alternative is not equal. Else it is a one tail. So that is nearly, it's easier to remember nearly when is it a two tail than to remember when is it a two tail or a one tail. So there's only one time it is a two tail, and that is when your alternative hypothesis is not equal to. Then I'm happy, then it nearly all else falls into place because then you don't need to go to the Z tables to get a critical value. You can use the one that is given in the table. So how do you know when hypothesis is not equal? So they need to, so let's look at, so in this one, they said to us it's bigger, so they didn't. In this one, they say not equal to. In, where was, so in a question like this, where they said the public swimming pool is greater than 7.5, to get the not equal, they would have said, okay, the swimming pool administrator says that the swimming pool is not 7.5. So they won't then say it's greater or it's smaller. They would just say it is not equal to 7.5. So that you're basically saying, okay, not equal, so it can be more, it can be less, it's not equal. Um, so they use that wording of not equal, or they will show you in the question, they will show you that it is not equal to. Okay, so I will get a few questions ready for the prep on Tuesday that will show you all of these differences, just that you can pick it up, because it's those small things that make it, um, that you get the answer right, or you get it wrong. And again, in your assignment prep, that is where you might get half marks or full mark, or 1 mark out of 2 or something like that. But in the exam, it's full mark or 0 mark. There's no half marks or anything like that. So we need to make sure that when you read the question, it nearly falls into place. You see it's bigger than one tail, 5%. Okay, one tail, 5%. Let's go to the table. Critical, one tail, 5%. The critical value is 1,645. So we will nearly get that type of structure for you guys when we now look at the recap, so that we just identify what the process is. So I will make sure when we do the recap that we follow that same process. Doesn't matter even what the answer set is or whatever, we will follow that same process, that you guys can just, when it comes in the assignment or comes in the exam, we know when it comes to hypothesis testing, yes, this process of 4 or 5 things that you need to do, to get to the answer. Okay, everyone's the recording. I will share it on the WhatsApp group again. I'll share the presentation on the WhatsApp group.